Ladies and gentlemen, welcome to tonight's debate on the topic of machine learning algorithms. Today, we have two prominent contestants representing two powerful algorithms, the decision trees algorithm and the naive Bayes algorithm. Let's begin with opening statements. Decision trees, you may start.
Thank you, moderator. Ladies and gentlemen, I am here to advocate for the decision trees algorithm, a versatile and widely used machine learning technique. Decision trees offer a clear and interpretable way to make decisions based on data. By recursively splitting data based on different attributes, decision trees create a tree-like model that provides valuable insights. This algorithm is effective in handling both classification and regression tasks. It's simple yet powerful, and can handle both numerical and categorical data. I believe that decision trees provide a solid foundation for effective and explainable machine learning.
Thank you, decision trees algorithm. Now, it's time to hear from the naive Bayes algorithm. Please present your opening statement.
Thank you, moderator. Ladies and gentlemen, I am here to represent the naive Bayes algorithm, a probabilistic classifier that has proven its worth in various fields. Naive Bayes is based on the fundamental principles of probability theory. It assumes that features are independent of each other, given the class label. This simplification allows for fast and efficient training and classification. Naive Bayes has shown remarkable performance in text classification, spam filtering, and many other applications. It is particularly useful when dealing with large datasets and high-dimensional feature spaces. Naive Bayes provides a strong foundation for probabilistic reasoning in machine learning.
Thank you, naive Bayes algorithm. Now, let's move on to the first question. Decision trees, what are the key advantages of your algorithm compared to naive Bayes?
Decision trees offer several advantages over naive Bayes. Firstly, decision trees are highly interpretable. The branching structure allows us to understand the decision-making process, making it easier to extract insights and explain the model's predictions. Additionally, decision trees can handle both numerical and categorical data, making them versatile for a wide range of applications. They can handle missing values and are robust to outliers. Decision trees also have the ability to capture nonlinear relationships between features, which can be beneficial in complex datasets. These advantages make decision trees a powerful tool for many real-world problems.
Thank you, decision trees algorithm. Naive Bayes, your response.
While decision trees have their merits, naive Bayes provides unique advantages as well. One key advantage of naive Bayes is its efficiency. Due to its assumption of feature independence, naive Bayes requires fewer parameters to be estimated, making it computationally efficient and suitable for large-scale datasets. Moreover, naive Bayes performs remarkably well in text classification tasks, where the independence assumption is often reasonable. It has also been successfully used in spam filtering, document categorization, and sentiment analysis. Naive Bayes is known for its simplicity, speed, and reliable performance in various domains.
Thank you, naive Bayes algorithm. Let's move on to the next question. Decision trees. Some critics argue that your algorithm is prone to overfitting. How would you address this concern?
Overfitting can indeed be a challenge with decision trees, but there are effective strategies to mitigate it. Techniques such as pruning, limiting tree depth, and setting minimum sample requirements for splitting can prevent overfitting. Cross-validation and ensemble methods, like random forests, can also enhance the generalization capabilities of decision trees. Moreover, by providing interpretable results, decision trees allow analysts to visually inspect the model and identify potential overfitting. It's crucial to strike a balance between complexity and simplicity to avoid overfitting, and decision trees provide the tools to achieve that balance.
Thank you, decision trees algorithm. Naive Bayes, do you have any thoughts on this matter?
Overfitting is a challenge that affects many machine learning algorithms, and naive Bayes is no exception. However, due to its simplicity, naive Bayes has fewer parameters to learn, which reduces the risk of overfitting. The independence assumption in naive Bayes also acts as a regularizer, preventing the model from becoming overly complex. Nevertheless, it's important to carefully handle feature selection and preprocessing to avoid introducing dependencies that violate the naive Bayes assumption. Overall, naive Bayes provides a robust and efficient solution, while still requiring some precautions to address the overfitting concern.
Thank you, naive Bayes algorithm. we have time for one final question. Decision trees, what do you believe is the most compelling use case for your algorithm?
Decision trees excel in situations where interpretability and explainability are of utmost importance. For instance, in the medical field, decision trees can assist doctors in diagnosing diseases by providing transparent decision paths. In finance, decision trees can be used for credit scoring, allowing lenders to understand the factors that contribute to a borrower's creditworthiness. Additionally, decision trees are useful in customer segmentation, fraud detection, and many other domains where comprehensibility and insights are crucial. Decision trees offer a valuable tool to make informed decisions based on data.
Thank you. Decision trees algorithm. Naive Bayes, what is your most compelling use case?
Naive Bayes has found great success in various fields, but one of its most compelling use cases is in text classification. With the exponential growth of textual data, Naive Bayes provides a fast and efficient method for categorizing large volumes of text into different classes, such as sentiment analysis, spam detection, or topic classification. Its ability to handle high-dimensional feature spaces and the assumption of feature independence make it a powerful algorithm for textual data analysis. Naive Bayes has proven to be an invaluable tool in information retrieval and natural language processing applications.
Thank you, Naive Bayes algorithm. That concludes our debate today. Both algorithms, decision trees and Naive Bayes, have presented strong arguments and highlighted their unique strengths. It's clear that both algorithms have valuable contributions to the field of machine learning. The choice of algorithm ultimately depends on the specific task, dataset, and requirements of the problem at hand. Let's appreciate the merits of each algorithm and continue to explore their applications in the ever-evolving world of artificial intelligence. Thank you all for joining us today.